Welcome back. Previously we have begun with the concept of theory of probability, and I hope we have just briefly mentioned the introduction concept of probability. Today we will be discussing about the methodological aspect regarding probability, in which we will be learning various terms and terminologies with regard to probability. Previously we have mentioned the concept of theory of probability and the scale and representation of a probability concept, how it is represented. Let us discuss some of the terms that we used in probability. First one, random experiments. Random experiment is an important term that you will be dealing with during the computation part or the methods and techniques which we are going to learn in the future sessions. Random experiment is an experiment that has two or more outcomes which vary in an unpredictable manner from trial to trial. When conducted under uniform conditions is called a random experiment. In a random experiment, all possible outcomes are known in advance, but none of the outcomes can be predicted with certainty. With an example, you will get a clear picture. Earlier I have mentioned about tossing a coin. Like if a coin is tossed in the air, you will get either head or a tail. So tossing a coin, that is known as random experiment. And I just mentioned that an experiment that has two or more outcomes. So tossing a coin was an experiment, and every experiment has two or more outcomes. Means after the implementation of that particular experiment, means you tossed a coin, the result of that experiment is you either get head or a tail. That is known as outcome. So an experiment that has two or more outcomes. In case of a tossing a coin, any single coin, if you toss in the air, you will have the probability of getting two outcomes, either head or tail. So that particular events are known as random experiment. Not only to coin, you will be come across examples where in the many of the problem area you will be using the term coins. Tossing coin probability is an important area, and another important case is dice. If you know, die means that it's square piece consisting of 6 sides having 6 numbers 1, 2, 3, 4, 5, 6. If you remember, in snake and ladders you will be using a die. You will throw that die, on the base of that die number only you are taking the moves. In case of a snake and ladder, in Ludo likewise, that is known as dice. In some books it will be mentioned as die, D-I-E. In some books it is used as dice, D-I-C-E. So whatever the terms, the concept is dice. So throwing a die is also a random experiment. Just like the theory mentioned, it also has more outcomes, because if you throw a die, the probability of getting 6 items are there. One, you can get 1, you can get 2, you can get 3, or 4, or 5, or 6, but you can't get a number other than 6. Other than 6 means more than 6. You can get a 7 in throwing a die. In case of a 6-sided die, that is the meaning. I hope you are getting the concept. So random experiment is whatever the probability area which you are going to study, that particular event is known as random experiment. So mentioned earlier, tossing a coin is an example of a random experiment. It has two outcomes, head or tail. Throwing a dice or a die is also a random experiment. It has 6 outcomes. So the thing is that we know that there are 6 outcomes, or in case of a coin there are 2 outcomes. We know what are the outcomes, but we don't know what is the actual event that going to happen. If you toss a coin, we know that head or tail will come, but we don't know whether we get head or tail. If you throw a dice, we know that we will get a number in between 1 and 6, including 1 and 6, but we can't surely say that the particular number you will get a particular number. So that is the meaning of the sentence. Experiment that has 2 or more outcomes, but none of the outcomes can be predicted. That is the meaning of random experiment. So the examples were dice and coins. There will be more than one outcomes, and most of the outcomes are unpredictable and repeatable. That is a concept of probability. You will not stop your experiment with just a throwing one time coin tossing or a one time throw of a dice. You never do it's a one time activity. It will be a repeated trial and error activity. You will do it numerous times. That is one of the essential feature of a random experiment. These are the main features of a random experiment. Almost all the random experiments have more than one outcomes, and we know that there are certain specific we are certain about the outcome, but we are uncertain about the event that is going to happen. That is, we can't predict which now event is going to happen. That is, random experiments are unpredictable, and finally it is repeatable. Next one, sample point, otherwise known as simple event or elementary outcome. These are the terms that are used synonymously in case of a sample point. Every indecomposable outcome of a random experiment is called a sample point of that random experiment. With the example, you will get a clear picture. When a dice is thrown, we know that every dice has 6 sides, 6 numbers, number ranging from 1 to 6. So each of these events or whatever it is known as sample point. So every random experiment or every event has number of sample points. In case of dice, we have the probability of getting 1 to 6, whatever the number, we don't know, but we have the probability of getting all these 1 or 2 or 3 or 5 or 6. So we have 6 sample points in case of a die. Whereas in case of a coin, you have 2 sample points, that is head or tail. So the events, total number of events from a particular experiment is known as sample point. I hope you are getting the concept. Next is sample space. The sample space of a random experiment is the set containing all the sample points of that random experiment. Therefore, the sample space of a random experiment is the totality of all the elementary outcomes of that random experiment. And usually the sample space may be finite or infinite. We will come to that part. Then before that, we will discuss with an example, then we will get a clear glimpse regarding that. So with the example, you will get a clear picture. When one coin is tossed, sample space is head and tail. Okay, because the outcomes of a coin is, one coin is head and tail. When 2 coins are tossed, the sample space are, you might get both head, you might get one is head and other is tail, you will get one is tail and another is head, and you might get both of the cases will be tail. So all these represent sample space. So then what is the difference between the sample point which we have discussed previously and what is the sample space? Sample point is the name given to that particular event. For example, when a coin is tossed, there are 2 options, head and tail. So sample point is head. One sample point is head, another sample point is tail. So sample point is the common name given to the events that comes out of that particular experiment. So samples, that is the meaning of sample point. Sample space means the total outcomes of that particular random experiment. That is the meaning of sample space. So when 2 coins are tossed, the events that going to happen, probability to happen is You might get two heads, you might get one head and another is tail, one is tail and another is head, both are tails. So remember the formation. See, head head, head tail, tail hand. See, head and tail hand, these two are two different events. So remember that. During the course of our explanation classes, you will come across a situation like this. In this case, example, there was two coins. You may come across a question where there will be 3 coins, 4 coins, likewise. So the answer will be more events. So we will come to that part. Right now, just understand the concept. Next one, a lot containing good and bad items. 3 items can be chosen. Prepare sample space. So sample point of that particular experiment is good, bad. See, good item is one sample point, bad item is one sample point. So sample space means how many events can be made. That is the total outcomes or all the outcomes of that particular experiment is known as sample space. So if you have there are bag containing good and bad items, 3 items can be chosen. How many sample space can be made? It's very easy. The answer is, see, you may get 3 good items from one lot. Sometimes you may get 2 good items and 1 bad, and in another chance you may get there is a chance that you might get 1 is good, 1 is bad and 1 is good. And another option, you might get 1 good, 2 bads. Likewise, see, total 8 events, 1 2 3 4 5 6 7 8 events can be made. So this is an example of sample space. I hope you are getting the concept. If you have any queries, please let me know. Next one, event. An event is a subset of the sample space of a random experiment. It may be simple or compound. With an example, you will get the clear picture. An event, if it is corresponds to a single elementary outcome of an experiment, it is known as simple event. For example, when a dice is thrown, the probability of getting the number 2 is an example of simple event. Simple event means the outcome of a random experiment. There will be only one outcome. That is known as simple event. Whereas the joint occurrence of 2 or more simple events out of an experiment is called compound event. With an example, you will get a clear picture. When a dice is thrown, what is the probability of getting an even number from a die? Definitely there will not be one even number. There will be more than one even number. That is 2, 4, 6. If you throw a die, the probability of getting a even number means you might get 2, you might get 4, you might get 6. So what is the probability of even number means you might get any of these 3 events. So the outcome of an experiment may be more than one outcomes. That is known as compound event. Compound means from a particular experiment, the probability of getting that particular experiment means there might be more than one events. So that is the meaning of simple as well as compound event. Next one, sure event, otherwise known as certain events or sample space events. An event whose occurrence is inevitable is called certain event. A sure include all the sample points. For example, getting a white ball from a bag containing all white balls. If you are given a bag containing 5 or 6 white balls, and what is the probability of getting a white ball? Definitely you will get a white ball, because in that bag there is no other color rather than white. So the probability of getting that white is sure. So whatever the event that is sure, it is known as sure events. In other words, it can be said as certain events or sample space events. So a sure event is therefore the set containing all the sample points of a random experiment. And a sure event is the sample space itself. See, sample space. So you need to familiarize all these terms, because during the computation part or the practical application cases, we will be using these terms in the questions. So you need to familiarize all these terms. So just go through it, familiarize all these terms. If you have any queries, please let me know. Next one, impossible event, otherwise known as empty set. I hope you understand the concept. If you understand the sure event concept, the impossible event need not require any explanation. Still, let us go through it. If an event cannot occur, that is, when the random experiment is conducted, then that event is an impossible event. For example, getting the number 7 when a dice is thrown. Can you get a number greater than 6? No. A dice consists of, that is, a 6-sided dice. Nowadays in the market you will be getting 6-sided, 8-sided, 10-sided dice. But for the time being we will be discussing only 6-sided dice. A dice doesn't have a number greater than 6. So the probability of getting any number greater than 6 is impossible, because there is no other number other than numbers within or less than 6 in a die. So impossible event, otherwise known as empty set, is an event that doesn't happen from a particular random experiment. And also another example is getting a white ball from a bag containing all black balls. It is surely an impossible event, because we won't get a white ball from a bag containing black balls. So an impossible event is otherwise known as empty set, as it contains no sample point of a random experiment. And as we have mentioned about the same case in the beginning of the set theory, an empty set is denoted by a sign 0, a line over the 0 line, that is represented by null set or empty set. Remember that usually impossible events are represented by like that, and in some problem areas you might need to represent the impossible event through that sign. So remember 0, a line over the 0 line. So an impossible event is an empty set and it contains no sample point. Next one, uncertain events. An event is said to be uncertain if its happening is neither sure nor impossible. It may or may not happen. We don't know whether it happens or not. That is, the happening of an uncertain event cannot be predicted. With an example, you will get a clear picture. Getting a white ball from a bag containing white and black ball is uncertain, that is sure. And if you throw a dice, the probability of getting 4, we know that the dice consists of one side with the four dots. But can you surely predict that you will get the number 4? No, we can't predict that. So that is known as uncertain event. We know that event, there is a probability of getting that event, but we can't say surely that you will get that number, particular number, by throwing that die. That is known as uncertain event. Next one, equally likely events. Two events are said to be equally likely. Usually, in case of two events are said to be equally likely if any of them cannot be expected to occur in preference to the other. For example, getting head or tail when a coin is tossed. We know that if a coin is tossed, you may get a head or a tail. That is, you have the chance of getting head or a tail. That is, you have the equal chance of getting any of these two events. One of these events will happen. That is known as equally likely event. For example, if you throw a dice, you get the 3 or 6 or whatever the number. Because all these events are likely to happen and they are equally likely. There is no probability that your chance of getting head is more than tail. You can't say like that. You can say that by throwing a coin you can get head or a tail. That is 50-50 chance. Equal chance. That is known as equally likely events. Next one, mutually exclusive events. It is almost something like equally likely event with some minor differences. We will discuss about mutually exclusive event in detail or in brief with regard to this probability concept in the next session. Until then, just go through all these areas which we have discussed. Familiarize and understand each of these terms because I have mentioned this numerous times. During the practical cases, you will be using all these terms, so you need to familiarize these terms, then only you will understand the question. Understanding the question is of great importance in case of probability concept. So let us continue with the sessions in the next one.